Good afternoon. I sent out a test 3 review handout, and anyway, I had attained or retrieved just like a sample from Alex, and again, so what I have sent you, okay, is just a bit of a composite of items from Chapter 2, and okay, and just for this particular set, again, you just have various topics from Chapter 2, and I tell you what, just sort of skipping around this set of problems, and I thought we might start out with some of the most recent items, and especially with the case of inequalities for polynomial functions as well as rational functions. And let's say that if we have, in the case of number 17, okay, and we have a function that is already presented in factored form, and it says to solve the following inequality, okay, whereupon we have the square of x plus 4 times the quantity of x minus 6 is said to be less than 0. And it says to write your response as an interval or union of intervals, okay, and it says if there is no real solution, okay, just indicate it as such, okay. And for what we have in the case of 17, okay, and okay, so we have with our function f of x, okay, so we have the square of x plus 4 times the binomial x minus 6 and just looking at what we have in the setup. Okay, now again, just taking what we have for this function, and again we have for the factored form, we can go ahead and readily obtain the zeros. Okay, so we have for the zeros of this function, okay, so we have with the first factor from x plus 4, okay, we have x equal to negative 4, and we have with the other binomial factor x minus 6, if I set this to 0, I would have that x is equal to 6, and I have the tools necessary to be able to set up a table of intervals. And just for what we have, once again, just looking at spanning what we have for the entire set of real numbers. Okay, so we have for our zeros, again, we have negative 4 and 6. Negative 4 is going to be the lesser of the two zeros. So for the smallest values of x, okay, we're going to have for those items of interest, we'll be looking at the values of x less than negative 4. And bypassing negative 4, we have next in line, we have those values of x such that negative 4 is less than x is less than 6. And we have for the rest of the values, can we have those that will be greater than 6. And just placing these intervals, okay, in a table. Okay, so we've got our distinct intervals, and now looking at just about to enter the phase of applying test values throughout. Okay, so we have among the test values, okay, that can be applied. Okay, so we have just for the first interval, okay, we can select anything that is less than negative 4, or like on a number line, anything to the left of negative 4. So it would have to be a value that is more negative than negative 4. So in this case, we could go with, say, negative 5. Anything between negative 4 and 6 we can test out. We can go with 0. And anything greater than 6, Okay, we'll just go with the number 7. And for what we have in the case of determining the output, which we have defined in general terms as f of x is equal to the square of x plus 4 times the quantity of x minus 6 and inputting the value of negative 5 for x. Okay, and we can just kind of go over this pretty quickly. For negative 5 plus 4, that's negative 1, and the square of negative 1 is a positive 1, and we have negative 5 minus 6 is negative 11, so you got positive 1 times negative 11, so f of negative 5 will end up at minus 11. Now for f of 0, with x set to 0, okay, so here we have 0 plus 4 is 4. The square of 4 is going to be 16. 0 minus 6 is negative 6. And 16 times negative 6 is going to be a negative 96. Now for what we have in the case of f of 7, okay, 7 minus 6 is 1. And 7 plus 4 is 11, and 11 squared is 121 times 1, and we still have 121. So we have a positive value for this output. And so for what we will have in terms of the sign of f of x, again, for the first interval, okay, the output is going to be negative. So we have the f of x is less than 0, anything greater than negative 4 and less than 6. Again, we have a negative output. Again, we have the f of x is less than 0, and anything put in for x that is greater than 6, the output is positive. Whereupon we have that f of x is greater than 0. And looking at, going back to what we have with our inequality, give me just a moment. There we go. All right, so we've got our table already established. And for what we have in the case of the inequality, so we're looking at where we have the result or the function to be less than 0. Okay. All right. So for this inequality, okay, we're looking at referencing where f of x is less than 0, and what we're going to get for the solution, we're going to have with the first two interval sections, okay, so for this statement to be true, we're going to have that either x must be less than negative 4, and if it doesn't fall in that category, we have the other possibility that x must be between but not including negative 4 and 6. Okay, so this union of intervals is going to be the solution for x and pertinence to that inequality. We have, again, n number 17. All right, now, for what we have in the case of number 18, again, just touching upon rational inequalities. Okay, and here we have x plus 4 over x minus 7 is less than or equal to 0. And for what we have in this particular item, okay, so we've got a rational function. I could put this down as f of x again, but I'm just going to put this as r of x. Okay, so you have x plus 4 all over x minus 7. Okay, and again, let me just mention, with the nature of the inequality, less than or equal to 0, the equal sign means that if there's an interval solution, we may or may not have a bracket. And this would be contingent upon whether any of the zeros that apply will be in the domain. Okay, so we got for this rational function, okay, so you have for the zeros of r of x. Okay, now if I set the numerator to 0, then I can have a 0 numerator as long as I do not have a 0 valued denominator. So if x plus 4 is 0, we have x equal to negative 4. And this will create a situation where r of x is equal to 0. So negative 4, this value is going to be in the domain. And for the other 0 value, this would be, we have with x minus 7 in the denominator. And if the denominator is equal to 0, well, the rational function is undefined. So this other 0 is not in the domain. And looking at setting up what we have for the intervals centered about these zeros. Okay, and we have between negative 4 and 7. Okay, comparing the zeros, negative 4 is the smaller. So we have for the extreme left values, okay, we're looking at those that will be less than negative 4. Then we have those between and not including negative 4 and 7. And for the remaining set, we have those values of x which will be greater than 7. And establishing the rows here. Okay, so we've got our test value. Again, we have for the rational function, okay, we have r of x is equal to x plus 4 all over x minus 7. And looking at solving, yes. Okay, so just looking at separating. Again, you can have a 0 numerator as long as you do not have a 0 denominator. So negative 4 in the denominator, whereas 7 is not. Okay, so for what we can apply for the test values in x, okay, anything less than negative 4, negative 5 is a possible choice. Between negative 4 and 7, we can go with the reliable 0 again. Anything greater than 7, okay, we can go with the number 8. And for what we have for the outputs, okay, so for r of negative 5, okay, we have negative 5 plus 4. Okay, so you have negative 1, and negative 5 minus 7 is negative 12. So again, you will have initially negative 1 over negative 12, and a negative over a negative is going to be a positive. So we have a positive 1/12. And for what we have in the case of r of 0, okay, so we have 0 plus 4 is 4, 0 minus 7 is negative 7. And we can go ahead and say that r of 0 is equal to negative 4/7. And for what we have in the case of r of 8, okay, you have 8 plus 4 is 12, 8 minus 7 is 1, so you have a 12-to-1 ratio. Okay, so for this output, we have a positive 12. And for what we have in the case of the sign of the rational function, okay, for inputs less than negative 4, okay, the output is going to be positive. Okay, so here we're going to have the r of x is greater than 0, and then we have for the second interval, we have a negative output. So we have the r of x is less than 0, and for the last, okay, we have a positive output. So we have the r of x is greater than 0. Okay. And again, so we have, in the case of the inequality, so that was less than or equal to 0. So referencing what we have from the table, okay, so we're looking at where we have r of x is less than or equal to 0, and again, since the inequality has an equal sign, we might have brackets in the mix, okay, but not necessarily a guarantee. Okay, so we have in the same directions where r of x is less than 0. So we are involving the limit values negative 4 and 7. And in terms of whether we're going to have brackets or not, again, is contingent upon whether we have the pertaining 0 in the domain. And for negative 4, that is in the domain. So you can just put a bracket around this value. And for 7, not in the domain, so that stays in the parentheses. And so for 18, this is going to be the interval solution for what we have for the rational function less than or equal to 0. All right, and just kind of looking at transitioning over to our other topics, and for today we'll be looking at just sort of the foundational elements, especially that kind of piggyback on the items that we've encountered from chapters R and 1. Yes?
Is there any way that you can do those number line questions? Because they were giving me a real hard time in Alex.
What, the number line questions? Let's see.
Yeah. Where you have to graph it on the number line.
Oh, okay. Let's see. Yeah, we'll get to that. But what I can do, okay, now just for a number line, you're talking about for inequalities by any chance?
I don't remember if it was inequalities or not.
Okay, yeah, we'll get to.
Yeah, but I don't know for sure.
Okay, yeah. Well, if it's what I'm thinking, yeah, we will get to that.
Thank you.
Mm-hmm. I'll tell you what. If we look in the case of number 3, okay, so we have an equation, okay, where we have a function set equal to 0, and it says, and we have in the variable w, and it says to solve, okay, for the variable, okay, and here we have we have w squared plus 10w plus 24, and we have times the quantity of 5w minus 15 and we have is equal to 0. Now technically it can factor both of these, and you can do it either beforehand before itemizing and setting each of the factors to 0, or you could just take these as the factors, going ahead and setting equal to 0, and then factoring later and then solving for w. And we mean by this, if I go ahead and set each of these two items to 0, so we've got w squared plus 10w plus 24 is equal to 0. And also have 5w minus 15 is equal to 0. And for what we have for w squared plus 10w plus 24, that is equal to 0. So I can factor, say we have w plus 6 times the quantity w plus 4 is equal to 0, and we have with the zero product property in this case. All right, so we have for w plus 6 equal to 0, we have that w is equal to negative 6. As for w plus 4 equal to 0, we'll have that w is equal to negative 4. And for what we have in the case of 5w minus 15 equal to 0, so we have a two-step linear equation, okay? And what I can do, okay, you can either divide the equation by 5, or it can just isolate 5w upon adding 15 to both ends. So 5w is equal to 15. And if I divide by 5, and we'll have that w is equal to 3. Okay, and so we're going to have a trio of solutions in the variable w. Okay. And so for the values of w that will make this equation true, okay, we have negative 6, negative 4, also 3. Now, for what we have in the case of the next item, and we have for number 4, okay, and it says that suppose that the polynomial function is defined as follows, okay, and this function is laid out in factored form, and it says to list each 0, okay, according to its multiplicities, and okay, now, so again we have for f of x, okay, so we got, let's go write this again, so we have f of x so you have 6x times the quantity of x plus 9 times the square of x minus 5. Okay, and we have times the cube of x plus 11. And looking for the zeros and their multiplicities. Okay. And again, multiplicities of zeros, okay, will pertain to the degree to which the corresponding variable factor is raised. Okay, so we got, in the leadoff now, we got the first variable factor is x, which we have to the first. Next we have x plus 9 also raised to the first. And for x minus 5, this is raised to the second. and x plus 11. Okay, that is to the third power. And in the case of the zeros, and the corresponding multiplicity value, okay, so just itemize in case you have your factors. You have x plus 9, x minus 5, as well as x plus 11. Okay, so think like this. Okay, so if you've got 6x is equal to 0 or x is equal to 0, x is already at 0. From x plus 9, we have negative 9. And from setting x minus 5 equal to 0, okay, we have that x is equal to 5. And for x plus 11, if that is equal to 0, we have x is equal to negative 11. And for the multiplicity, okay, so 0 stems from the x factor, which is first degree. Negative 9 stems from x plus 9, which is first degree. And we have with 5, this comes from the square of x minus 5. So that multiplicity is going to be at 2. And with negative 11, okay, its multiplicity, okay, is indicated by the third degree to which the corresponding factor x plus 11 is raised. Okay, so 0 and negative 9 have a multiplicity of 1. 5 has a multiplicity of 2. And we have minus 11, which has a multiplicity value of 3. Okay. And now, for what we have regarding intercepts, and we have with this function, okay, we have a cubic trinomial, and for this function, okay, so we've got f of x is equal to 2x cubed plus 2x squared minus 24x okay. Again, we're looking just for the intercepts. Okay, and again, so for the x-intercepts, okay, I'm solving for x as y is set to 0. And if we look at the x-intercept first of all, okay, so y is symbolized in functional notation as f of x. And if we set this part equal to 0, okay, so we got 0 is equal to 2x cubed plus 2x squared minus 24x. Okay, and here we have a factorable trinomial. Okay, and the greatest common factor, you've got even numbers here, and also we have present the letter x. Okay, so factoring out 2x. Okay, so got 2x into the first term becomes x squared, and next we have plus x. And 2x into negative 24x is going to be negative 12. Again, factoring further is optional. Either pathway we take, we're still going to have 3 distinct values for x. Okay, and so we have with x squared plus x minus 12. Okay, we'll have, looks like what's going to be x plus 4 and x minus 3. Okay. And so we're going to have for the values of x, okay, so if 2x is equal to 0, we have x is equal to 0. If x plus 4 is 0, we have negative 4. And for x minus 3, okay, we're going to have that x is equal to 3. Right. And then, again, if you had to put this as ordered pairs, okay, we're looking at the origin as well as negative 4, 0. Also we have 3, 0. And in the case of the y-intercept, and this one is going to be quickly solvable, okay? Because again, we have the function is already in terms of y equals, or in this case, y is equal to f of x, where x is at 0. Okay, so inputting the value of 0 for x in the display. Okay, so you got all three terms here will become negligible, and so we're going to have that y is equal to 0, and in ordered pair terms, again, we would have the origin simultaneously being an x and y intercept, and it is the only point that can be both types, x intercept and y intercept. Okay, and in Alex terms, okay, so we have for the x intercepts, okay, Alex likes it in terms of not having the ordered pairs laid out. So you're just looking at the x values for the x intercepts. Okay, so that's going to be 0, -4, and 3. And for the y-intercept, it's just the y value of interest, okay, and that is going to be 0. So again, we have, for y we have 0, and again for x we have 0, -4, and +3. Okay. Now, for what we have in the case of the next item, we'll save the graphing parts for right now. If we look at number 8, it says to find a polynomial of degree 3 that has the following zeros. And it says technically to leave your answer in factored form. And for what we have in the case of number 8, okay, so we've got the zeros. So we have -3, 1, and 0. And now for the factored form, a factored form, okay, this is going to be a short answer item. So you can see we have with f of x, and setting up a factored form, okay, they'll be in correspondence to, in this case, x equal to -3, x equal to 1, and x equal to 0. Okay, and we say that x equals -3 stems from x plus 3. And for 1, okay, we can say this stems from x minus 1. And 0, we can say this stems from the variable x. Okay, so this is going to be the factored form. And let's say that if the problem had asked, okay, for the expanded form. Let me do this. Okay, so we got f of x in the factored form. So you have x plus 3 times the quantity of x minus 1 times x. Okay, and just for an expanded form, okay, if I take the product of the binomials, okay, so we have f of x, and foiling out x plus 3 and x minus 1, okay, we'll have x squared, outside product is -x, inside we have a positive 3x, added together, so we have 2x, last product, we have a -3, and again we have that result, okay, is going to be multiplied by x, so we have as an expanded expression. So we would have that f of x is equal to x cubed plus 2x squared minus 3x. Okay, and so if you had to write this out in expanded form, okay, this is one case. All right, now for what we have in the case of polynomial division, and we have for number 9, okay, we're looking at division where we have this third order polynomial is divided by the binomial 3x plus 1, and we're looking at attaining, okay, the quotient and remainder. Okay, and for what we have in the case of number 9, okay, now I would like to be able to use synthetic division, and if I had the binomial to be x plus 1, I could set things up directly in terms of synthetic division, but with the coefficient 3 in front of the x, the 3, okay, creates a bit of static because the 3x plus 1 is not of the form x minus c or x plus c, okay, because that 3 is kind of, again, it kind of rocks the boat, so to speak. And so for the polynomial division, okay, we can just have this set up in terms of long division. So we have the divisor at 3x plus 1. And for what we have in the case of the polynomial dividend, so we have 9x cubed then we have plus 18x squared, then we have plus 17x plus 6. And just double checking now for the dividend, there are no missing degree terms. So you got a third order, second order, first degree term in x, and we have closing out with the constant. Okay, so I can begin the process of the long division. Okay, so we have for 3x into 9x cubed. Okay, that's going to go 3 into 9 is 3. X into x cubed is 3x squared. So the first term, the quotient, okay, is going to be 3x squared. And distributing over the divisor. So we have 3x squared times 3x. Okay, that'll be 9x cubed. And 3x squared times 1 is 3x squared. And again, with long division, we're looking at row by row subtraction. And again, at each stage, the object is to get the leading term from the dividend and anything that spins off from it to go out. Okay, so we will have 9x cubed to go out upon subtracting. Now we have in second degree, we have 18x squared minus 3x squared, so we'll have 15x squared. And bringing down the 17x and the 6. Okay, so for the next stage, we can sort of hit the reset button. Now, the leading term, we have transition from 9x cubed to 15x squared. And I can take 3x into 15x squared, which will go 5x times, and distributing. So you got 5x over 3x is 15x squared. And 5x over 1 is going to be a 5x. Again, looking at subtracting, so 15x squared minus itself goes out, and we've got 17x minus 5x. So this will be 12x. We have plus 6. And then we have the attainment of one more term in the quotient. So I can take 3x directly into 12x, which will be 4 times. And distributing, so we have 12x plus 4. And so we have subtracting, so we have 12x minus 12x goes out, and 6 minus 4 is going to be at 2. So for what we're going to have in the result, okay, for the quotient and remainder. Okay, so it's going to follow that. The quotient, again, we have a 3x squared plus 5x plus 4. And again, I got the remainder at 2. Okay, reason being that I cannot take 3x directly into 2, so anything that stays after the division has run its course, okay, that's going to be the remainder. And it could be a constant or a variable expression. Okay, so for number 9, again, so with the quotient, okay, so again we have 3x squared plus 5x plus 4. And again, we have the remainder to end up at 2. All right. Now, where we have synthetic division, okay, to arise, okay, and it says here, okay, that we have the dividend, which we have as a fourth order polynomial. Okay, so we have it 2x to the fourth plus 10x cubed plus 9x squared minus 7x plus 5 is divided by x plus 3. Okay, and it says to complete the synthetic division table below and to write the response in the following form, where we have the quotient plus the remainder over the divisor. Okay, and let me mention, okay, so we have originating. Okay, so we have divided by x plus 3. And if I have x plus 3 equal to 0, so I have x equal to negative 3. Thus, you have the setup as it is. And we're trying to squeeze in these numbers here. Okay, so we have with the boxed in values. Okay, all right. So again, we have with synthetic division. Okay, so the leading term in the dividend is also going to be the leading term in the quotient. So I'm going to bring down 2. So having that square, so you have the number 2. And then we have negative 3 times 2. Okay, so this will be negative 6. And 10 plus negative 6 is going to be a positive 4. Then we have negative 3 times 4 is negative 12. 9 plus negative 12 is negative 3. Negative 3 times negative 3 is positive 9. Negative 7 plus 9 is 2. Negative 3 times 2 is going to be negative 6. And 5 plus negative 6, again, that is going to be at negative 1. So just kind of cleaning this up and just kind of using the other synthetic division notation. So again, we have 2, 10, 9, negative 7, and 5. Again, just with the numbers. Okay, so I got 2, negative 6, 10, and negative 6 is 4. Negative 3 times 4 is negative 12. 9 plus negative 12 is negative 3. Again, negative 3 times negative 3 is 9. Adding to negative 7, so we have 2. Negative 3 times 2, again, is negative 6. 5 plus negative 6 is negative 1. Okay, so we have with the last column total. Okay, so the remainder is at negative 1. And for the digits before negative 1, this will make reference to what we have in the quotient. Okay, so the quotient, again, the dividend 2 was in reference to 2x to the fourth. And in the quotient, this 2 is going to reference 2x cubed. Then we have for the digits that follow, we'll have plus 4x squared minus 3x plus 2. Okay, and just looking at writing, okay, in terms of quotient plus the remainder of our x plus 3. And again, I cannot write all that into these boxes, but basically what this ratio is going to be equal to, we have for the first box, okay, you have 2x cubed plus 4x squared minus 3x plus 2. Then we have plus, and then we have inside the box, we have negative 1 all over x plus 3. Okay. And so that'll be the layout for the quotient and the remainder over the divisor. Okay. Now, looking at what we have for number 11. And it says here to use the remainder theorem to find p of 2, okay, for p of x is equal to x to the fourth minus 2x cubed minus 5x squared plus 3. And it says specifically, okay, give the quotient and remainder for the associated division and the value of p of 2. Okay, so for what we have in the case of number 11, okay, all right, so you got p of x okay, so you have x to the fourth minus 2x cubed minus 5x squared plus 3. And again, we're looking at, okay, what the value of p of 2 is going to be. Okay. And first of all, okay, I can take what I have for establishing, okay, or the attainment of the quotient and remainder. Okay, and so you got your 0 value from the divisor at 2. And if I set things up along the lines of, say if I look at setting up along the lines of synthetic division, now I want to go that route. Okay, first of all, okay, we have with the coefficients. Okay, so 2 we have pertaining to the divisor. Now for the dividend, okay, we have x to the fourth. So for this leading term, the quotient, I should say, leading term, the dividend, okay, the coefficient is at 1. Then we have negative 2x cubed. So we have a negative 2. So I'm going from a fourth order term to a third order term. Now to the second order term, it has negative 5. And if you notice, we do not have an x term. So I need to create a 0 placeholder. Okay, so you got 1, negative 2, negative 5, and 0 for the missing first order x term. And again, we have 3 at the end. Okay. And just setting things up. Okay, so we got 1 brought down. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. Negative 5 plus 0 is negative 5. And we have 2 times negative 5 is negative 10. 0 plus negative 10 is minus 10. And we have 2 times negative 10 is negative 20. And we have 3 and negative 20. Okay, so you have at minus 17. So just looking at what we have now. Okay, so we're going to have the last column total. Okay, so you have the remainder is at negative 17. And for what we have in terms of the quotients, I'm going from x to the fourth to x cubed. Okay, if you notice, we have a missing x squared term. And I think in terms of how Alex would want the quotient to be written, it's like not even have the 0 coefficient in the answer. Okay, so you can just write this as x cubed minus 5x minus 10. Okay, so this will be the quotient. And in the case of what we have with the remainder, again, that is at negative 17. Okay, and in terms of the value of p of 2. Again, the remainder and the value of the function at the specified input, okay, those will be one and the same. Okay, so in this case, we had that p of 2 is equal to negative 17. All right. Now, for what we have in the case of the factor theorem, okay, and again, this goes hand in hand with the remainder theorem, okay, and we're looking at whether x plus 3 is a factor of p of x is equal to x cubed plus 4x squared minus 9, okay, and in terms of the fill in the blanks and determining whether or not x plus 3 is a factor, we can kind of put what we have also in terms of synthetic division. And let me mention, Casey, you got p of x and we have is equal to x cubed plus 4x squared minus 9. And if I'm going to set things up in terms of synthetic division, you notice I have a missing first order x term. So I'm going to use 0 for placeholder purposes. And in the case of x plus 3, okay, now remember, if x plus 3 is equal to 0, we have that x is equal to negative 3. And we have in terms of synthetic division, so just setting things up along these lines here. So you got negative 3. For the coefficients of the dividends, you have 1 for x cubed, 4 for the x squared, again 0 for the missing first order x term. And again, we have the last item, okay, we have at negative 9. And with the synthetic division setup, okay, so and the leading coefficient from the dividend is brought down. Then we have negative 3 times 1 is negative 3. 4 plus negative 3 is positive 1. Negative 3 times 1 is negative 3. 0 plus negative 3 is minus 3. Negative 3 times negative 3 is a positive 9. And negative 9 plus 9 is 0. Okay, and so we're going to have, in this case, we had that the remainder is equal to 0. And for what we have for the quotient, I'm just going to mention, for the quotient, again, we're going to have going from x cubed to x squared. So the quotient we have x squared plus x minus 3. Again, the remainder is 0. So for what we'll have in terms of filling in the blanks, okay, so you have p of what, and that's going to be p of the 0 of the divisor x plus 3. So that is going to be negative 3. And again, with the remainder value at 0, p of negative 3 is going to be equal to 0. So but you have to be the remainder. And if the remainder is 0, then you're going to have the divisor to be a factor of the polynomial. Okay? And if I had a non-zero valued remainder, it would not have been a factor. So we got p of negative 3 is equal to 0. Again, the remainder. And with 0 as a remainder, we have x plus 3 does turn out to be a factor. All right. Now, just going back to inequalities at the moment. Okay, and it says here, it says to graph the solution to the following inequality on the number line. Okay, and right now we've got an inequality in the form of x squared minus 2x is greater than or equal to 8. Okay, so I have this inequality statement, and as we have done before, I can translate to what we have as a comparison to zero item. Okay, so what I can do here is I can move the 8 over to the left and say that we have x squared minus 2x minus 8 is greater than or equal to 0, and this would just sort of set the stage up for what we have in the case of where f of x is greater than or equal to 0. Okay, so we have in the translation. Okay, so for the zeros establishing from the rewrite as a comparison to 0 inequality. Okay, so if I were to set x squared minus 2x minus 8 is equal to 0, and to look at factoring. Okay, so we have with our factors of negative 8 whose sum or difference will be at negative 2. Okay, so we'll have more weight given to the subtracting than to the adding. Okay, so we have with x minus 4 equal to 0. Then we have that x is equal to 4. And we have with x plus 2 is equal to 0. Okay, so we have that x is equal to negative 2. All right. So for what we have in setting things up, okay, so we got f of x is equal to x squared minus 2x minus 8. And again, having established the zeros. So for the zeros of f of x, we're going to have at 4. And also at negative 2. Okay. All right. And so setting up a table of intervals. Okay, so you have centered about on the 0 values of 4 and negative 2. Okay, so just rank ordering from negative to positive infinity. Okay, so we have the smaller of the two zeros at minus 2. Okay, so we have at the lower ends, we have those values of x less than negative 2. And bypassing negative 2, we now have the next set to be the values of x such that negative 2 is less than x is less than 4. Then we have for the rest, we have those values of x which we have to be greater than 4. And looking at establishing tested values for the input in accordance with the set of numbers for each interval above. Okay. First of all, anything less than negative 2, okay, negative 3 is such a value. And between negative 2 and 4, we can once again go with 0. And anything greater than 4, okay, we can select the number 5. Okay. And we have, for the case of, yes, we have f of x at x squared minus 2x minus 8. All right. Okay, so for what we have for starters, okay, so we have with our inputs. Okay, and we have -3 to start out with. So we have an f of -3. Okay, so if I plug in -3 for x, now we're going to have the square of -3, so that'll be 9. -2 times -3 is a +6. Then we have -8. And the result is going to be a +7. Now for what we have in the case of f of 0, okay, so you got 0 squared is 0, -2 times 0 is 0, and 0 minus 8, okay, this will come out to -8. And for what we have in the case of 5, for f of 5, okay, so you got 5 squared is 25, -2 times 5 is -10, and so we got 25 minus 10 is 15, and with -8 to follow, okay, we're going to have, just like f of -3, f of 5 also comes out to 7. And just looking at what we have now, okay, so we have the first interval section, okay, we have the output to be positive, middle we had to be a negative, and for the last, okay, we have a positive. Okay, so looking at the sign of f of x, okay, so in the first case, okay, so you have a positive output. So we have the f of x is greater than 0. Next we have a negative. So we have the f of x is less than 0, and then we have for the last, we have a positive. So we have the f of x is greater than 0. Okay, so for the inequality we started out with, okay, again we had to translate in terms of a comparison to 0 inequality in order to be able to set up this table above. Okay. Alright, so you had x squared minus 2x was greater than or equal to 8. And this translated out to x squared minus 2x minus 8 is greater than or equal to 0. Now we're looking at where we have that f of x is greater than or equal to 0. And where we have f of x to be greater than or equal to 0. So we're looking at the first and the last interval sections. Okay, now as an interval solution, I'm also going to apply this as a graphing solution. Okay, so we have at the one end, okay, so you have for f of x is greater than or equal to 0. So we're looking at referencing the limits of negative infinity and -2, and also 4 and infinity. And for what we have in terms of the enclosures, okay, now infinities are boundless, so they stay in parentheses. And for the equal to part, there is potential for there to be brackets, and both -2 and 4 make the equal to 0 portion possible. And so -2 and 4, they are both going to be in the brackets. So this will be our interval solution. And for what we have, say, as a graph on a number line, and for the extremes, we're going to have continuity at both ends. Okay, so for the left half, we're looking at those values x to the left of and including -2. Okay, so -2 is part of the system, so we have a solid point on -2, and the rest of the values, okay, from this interval section will be to the left. Okay, so you have a ray that will go continuously out in that direction. And for what we have for the second interval portion, we're looking at those values of x that will be greater than or equal to 4. And so we'll have a solid point on 4. And we have the rest of the values will be greater than. And so we're going to have a ray that will go in the other direction. And so we have going out to the right. Okay. And so that'll be the graph solution of what we have for that particular inequality. All right. And let me just round out what we have here for, let's see, where was it? Yeah, for 16. Okay, let me squeeze this one in right fast. 16, you're looking at where x plus 2 times x minus 4 times x plus 6 is greater than 0. Okay, so we've got our inequality. Okay, we're just looking at the interval solution. All right, so we have in the foundation. Okay, so we got the function in factored form. Okay, so you have this trio of binomials. Okay, and since f of x is given in factored form, okay, say that for the zeros we'll have -2, +4, and -6. And setting the stage, okay, to determine what set of values of x will comply with this particular inequality. Okay, so we're looking at whereupon we have f of x is greater than 0. Okay, and so we have with our interval sections, okay, and we have -6 to be the smallest of the zeros. So we have at the first end, or lowest end, we have values of x less than -6. Then we have those values of x between -6 and -2. Then we have those values of x between -2 and 4. Then we have those values of x, okay, which will be greater than 4. And so for the test values in x, okay, so anything less than -6, I can just go with -7. For the next, I'll go with -3. Between -2 and 4, I'll go with 0. And anything greater than 4, I'll just go with the number 5. Again, so we have with our function. Okay, so you have x plus 2, x minus 4, x plus 6. Now for the input value of -7, okay, so we got -7 plus 2, that is -5. -7 minus 4 is a -11. -7 plus 6 is -1. And this output, okay, so this will end up at -55. For what we have in the case of f of -3. Okay, so you have -3 plus 2 is -1. -3 minus 4 is -7. -3 plus 6 is going to be +3. So this output is going to be at 21. Now for f of 0, okay, this one will have 2 times -4 is -8 times 6, so we'll have -48. And for f of -5, make that f of 5, got 5 plus 2 is 7, 5 minus 4 is 1, and we have 5 plus 6 is 11. And so we're going to have 7 times 11, so this will be a +77. And so for what we have in the case of the sign of f of x, first interval, okay, we have a negative. We have less than 0, next is positive, whereupon we have the f of x is greater than 0. Third, we have a negative, whereupon we have the f of x is less than 0. Then we have for the last, okay, we have a positive. Okay, so we're going to have that f of x is greater than 0, and leading up to our interval solution. Okay, so this is the inequality we started with, and we're referencing where f of x is greater than 0. Okay, and this will pertain to the second and last interval portions. And so for the interval solution, we have with the second and the fourth. So it's going to be those values of x such that negative 6 is less than x is less than negative 2. And you have along with those possible values of x such that x is greater than 4. And so this will be your interval solution where you have the union of these two.